am I audible? Can you all hear me well? Okay. Then we can start the class. Today's topic is continuity. We all are familiar about the continuous functions. Suppose we have one function fx. It's a real valued function from suppose a to r. And we are considering one point. Yes. Okay. We have one real valued function fx from a to r and c be any point. Then when we will say that fx is continuous at c, what is the definition? The preliminary definition. I am not asking for the epsilon delta concept. What's the definition of continuity? When we will say that fx is continuous at the point c. You already learnt it in 11th or 12th class. We will say fx is continuous at c if the left hand limit and the right hand limit both are same and both are equal to the functional value. That means this. Limit extending to c plus fx and limit extending to c minus fx equal, and they both are equal to fc, that is the functional value of the function f at the point c. Then we will say that fx is continuous at c. Okay, so this is the preliminary definition of a continuous function at a particular point. Now we have to know about the epsilon delta concept of continuity. Like limit, we already know for limit. Now the concept is for continuity part. The definition states that let f from a to r be a function and c belongs to a, be any point. Not necessarily limit point. It could be a limit point, it may not be a limit point. So c belongs to a and f is said to be continuous at the point c if for pre-assigned epsilon greater than 0 there exists a delta depend on that epsilon greater than 0 such that modulus of fx minus fc is less than epsilon for all x minus c less than delta. Okay. This is the definition of epsilon delta definition of continuous function. So what is it saying? It's saying that f from a to r be a real valued function and c be any point belongs to the domain of f, that is domain of the function. Then at that point f is said to be continuous if for pre-assigned or pre-given epsilon greater than 0, that means whatever epsilon you can choose. For any epsilon greater than 0, there must exist one delta such that fx minus fc, this quantity should be less than epsilon for any value of epsilon. Epsilon is pre-assigned, we can choose whatever large, whatever small epsilon we want to. So for any epsilon, this difference always less than epsilon for all x belongs to x minus c less than delta. Now check, unlike the definition of limit, there is no greater than 0, right? So if we expand this part, what will we get? Minus delta less than x minus c less than delta. That means c minus delta less than x less than c plus delta. That is c is included here. Okay. So if this is real line, this is c minus delta, this is c plus delta. So for this region, the whole thing is true and c is included here. That means the point where what we are discussing about need not to be excluded, like the definition of limit, because always at the point c the function will be continuous. Why? Because if you put c here in this definition, in this line fx minus fc less than epsilon, if you put x equals c, what will you get? Fc minus fc, right? Which takes the value 0, which is obviously less than epsilon. No need to find any delta, because for all delta 0 is always less than epsilon, because we know epsilon is always greater than 0. So no need to say anything about the point c. This is why the c point is included in that interval, and this is why, unlike the definition of limit, we won't use greater than 0 sign here. Okay, remember this. This is the difference between the definition of limit and continuity. Here c is included because obviously the function will be continuous at the point c. As you can see, if we put x equals c, this is obviously 0, which is less than epsilon. Okay, so this is the epsilon delta definition of continuity. Now I will give you few examples. You have to check using epsilon delta concept that this is continuous at a particular point or not. Okay, write down example. Check whether the given functions are continuous or not on R. R means real numbers. These are the functions. Total 5 functions are given here. We have to check one by one that these are continuous on R or not. Obviously using epsilon delta definition. Here, like the definition of limit, we also have pre-assigned epsilon in our hand. Using that epsilon, we have to find out the value of delta. Okay, so this is the main parameter here, delta. We have to find the value of delta. So tell me the first one. How will we solve it? First one is very easy. Fx equals k, constant function. Okay, as it is the first one, I am telling it. Starting with fx minus fc, where c is any point belongs to the domain. Okay, so fx minus fc. What is the value of fx? It is k given. And what is the value of fc? What is the value of fc? K. Yes, because f is a constant function, it will take the same value on each point. So f is also k. K minus k is 0, which is obviously less than epsilon, as we have epsilon always greater than 0. So this is true for every delta greater than 0. That means if you choose any delta, any positive delta, this will satisfy this. This is the answer. That means the function is continuous on R, because we have chosen any arbitrary point from the domain. So continuous on every point. Okay. Next, moving to number 2, fx equals x. Now someone tell me how to solve it. This is also very easy. What will be the value of delta here? You have to find out the value of delta. I could epsilon, delta will be equal to epsilon. Okay, it's correct. Just explain it a little bit. How will you get that? Yes, this equals x minus c. And we know that for the definition of continuity, x minus c is always less than delta. And we choose this is equals epsilon. So here delta equals epsilon. So this is also continuous on R. Okay. Next is fx equals x square. Number 3. Starting with fx minus fc, x square minus c square, that means mod x plus c into mod x minus c. Now check, mod x minus c is always less than delta, right? So it won't create any problem. The problematic part is this part, x plus c, and there is variable part also, x. So somehow we have to find out some upper bound for that part, that is some replacement for x by some constant value. Okay, so for that reason what will you do? Just like the limit problems, exactly the same thing we have to do to find the delta. Just like you have solved the limit problems. Forget about continuity. If it is a limit point, then what would you do to solve it, to get the value of delta? we have to choose one preliminary value for delta, naming it delta 1, right? So let delta 1 equal to some c by 2 or c by 3 or c by 5, like this. I'm taking c by 2. Then we have the formula, that is x minus c is less than delta 1, right? Put the value and get an upper bound for x. Put it. We need an upper bound for this function, x plus c. At first get one upper bound for x, then we will make it for x plus c. All of you got the value of upper bound for x? What's the upper bound value? Check from this line. What is the upper bound for x? 3c by 2. Now check our functional value, that is fx minus fc. We need an upper bound for this part, modulus of x plus c. So what will be our next step? From this line, what will we do? Add c on each side. So c by 2 plus c less than x plus c less than 3c by 2 plus c. That is right. So using that part, what we can write from fx minus fc? So from fx minus fc we got this value is equals mod x plus c into mod x minus c. Now we can write that this quantity is less than, for this part, 5c by 2 into x minus c, right? Now x minus c is less than delta. So this part will be less than epsilon if modulus of x minus c is less than epsilon by 5c by 2. That is if is less than 2 epsilon by 5c. Now this quantity, we always know that modulus of x minus c should be less than delta. So for that reason we are choosing this part as delta 2. So we get our required delta equals minimum of delta 1 comma delta 2. That is minimum of delta 1 was c by 2 and new delta 2 is 2 epsilon by 5c. This is our required delta. For this delta, we can claim the function is continuous on R. Okay, just like the limit problems, exactly the same concept. Take one preliminary value for delta, naming it as delta 1, then use this to solve the problem, and then after that the required delta will be the minimum value of delta 1 and delta 2.